This video is a video using the TI-84 Plus Silver Edition calculator to discuss how to calculate measures of variation. There are three main types of measures of variation that we cover in this course, the first being standard deviation, the second variance, and the third one range. Just to remind you, variation is basically to show how data is dispersed or how it is spread out. So first we're going to use the graphing calculator to calculate these values for us. So example 1. The number of students enrolled in all LSUE Math 0021 courses for this fall semester are listed below. So one class has 6 students, one class has 19, 25, 21, 19, 6, 22, and 28 students. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8 different classes. So the first thing you always want to note, are you dealing with a sample here or are you dealing with a population? Well, since we listed the number of students in all of the math classes, we're dealing with the population. If it would have stated something like randomly selected for math classes, that would have been a subcollection or a sample. So here we're dealing with a population. So the first question is find the standard deviation. So I'm going to go ahead and go to the calculator. You have to enter all of the data values into a list. So first press the Stat button, and for time's sake I actually already entered the data values. You should know how to do that from the previous section. Press Enter to open the Edit menu, and I've already entered my data values here into the list. There should be 8 data values. And so to actually calculate the standard deviation, you press the Stat button, select the right arrow key to highlight the word Calculate at the top of the calculator, and the very first option is One Variable Statistics. Either press 1 to open up this menu or press Enter. Under List, you have to type in the list where you entered the data. So I entered it into list 1, so second, then the number 1. Scroll down using the down arrow key. Frequency list you leave blank. Scroll down again to highlight Calculate, and then you press Enter. So from the previous section, we already calculated the mean, and we skipped over a lot of this information. Well, now we're actually going to be using the S here, which represents standard deviation for a sample, and the sigma here represents the standard deviation for a population. That is why it's so important to note whether you're dealing with a sample or a population, because notice these two numbers are different from one another. In this case, we're dealing with a population. So you would use the second option here, sigma, which denotes the population standard deviation. So you don't have to use a formula. The calculator does it for you. So the population standard deviation sigma is 7.611668674 and so on. But of course you round one place past the data, so that's to one decimal place. So the standard deviation of the data set is 7.6 students. Second question, find the variance. Well, once you've already found the standard deviation, the variance is very, very easy to find. All you have to do is square whatever the standard deviation is. So the variance is equal to the standard deviation squared. So we found in number 1, the standard deviation for the population was 7.611688674. You simply take this number, the standard deviation, and you square it. That was approximately 57.9375. Once again, you have to round, so the variance is 57.9. The variance honestly isn't used all that much anymore. They may ask you to find it in some problems, but we're going to mainly use standard deviation. The last one, find the range. Well, the range is a very easy formula. It's the highest value in the data set minus the lowest value. Well, the highest value is a class with 28 students, minus the lowest value is a class with 6 students. So 28 minus 6, the range of the data set is 22. The range of the data set, notice, uses only these two values, right? If we were actually to calculate the standard deviation by hand, you can think of it as an average distance. The standard deviation represents, on average, how far all of the data values in the data set deviate from the mean of that data set. The mean was 18.25. So if we were to actually go through and use the formula, what the standard deviation is on average, how far do these numbers deviate away from 18.25? So I always like to talk about standard deviation as an average distance. So next question. Using the range rule of thumb, give a range for significant values and not significant values. Determine if having a Math 0021 class with 36 students is significantly high, significantly low, or not significant. Well, recall from the previous section, 3.1, the mean number of students was 18.25. You can also see that up here, the calculator. And from the previous example we just did, the standard deviation was 7.61. Using the range rule of thumb, you need those two things. You need to know mu, or your mean, 18.25, and you need to know your standard deviation, 7.61. So what the range rule of thumb tells us is that if you start at the mean, which is 18.25, and you subtract two of these average distances, or two standard deviations, that's going to give you a lower number. So 18.25, the mean, minus 2 times your standard deviation, which was 7.61, you end up with 3.03. And if you add two of these average distances, so starting with the mean, 18.25, plus 2 times the standard deviation, which is 7.61, you end up with 33.47. This gives you a higher number over here. What this tells us is values that we consider significantly high, significantly low, or not significant. So values over here on the left side are below the average, would be significantly low because they are below the mean. So any class with 3.03 students or lower is considered a significantly low number of students. Any class with 33.47 students or higher is considered a significantly high number of students. And any class between 3.03 and 33.47 is not a significant number of students. So what this is telling us is that if we have a class with, let's say, 7 students, 7 falls in between 3.03 and 33.47. So that's not a significant number. If we have a class with 37 students, well, that's above the 33.47, so that's a significantly high number of students. And if we have a class with only 1 student, that is below the 3.03, so that is a significantly low number of students. So to answer the question, is 36 students a significantly high number of students for a Math 0021 class? Well, 33.47 or higher is considered a significantly high number or a very large class. So 36 students is significantly high number of students for a Math 0021 class.